For this tutorial, we're going to talk about coding style, which is what your TAs will be marking. Part of what your TA is going to mark. So first, why does code style matter? Because you write your code once and read it many times and modify it many times, both by you or by others. And which is why it is important to make your code easy to read and understand for everyone. And if you need to come back to it later, it is really likely that you will forget about it. So it's also easy for you to read. Code which is hard to read is bug prone. It is hard to debug. It is difficult to modify because you must understand it first. And it's challenging to reuse. If your code needs to be used by someone else later. Oh, yes.
So it's connecting to this, yeah? That's the problem?
Oh, yeah, it showed up.
Oh, okay, good.
Okay, thank you.
Okay.
Thank you. Yeah. Yay. We have the screen right now. So today we're going to discuss the aspects of coding style. So first, the functions needs to be short. And if you have long blocks of code in a function that describes a certain behavior, we recommend you make it into helper functions that are called within the function. The variables need to have proper naming. You need to use temporary variables, and your variable naming should be reflecting your scope. Comments needs to be throughout the code and need to be meaningful. If you just want to add in comments that means nothing, that also means deduction of mark. Avoid duplicated code. Group data with classes and data structures. Make sure your code has no warnings. Write self-checking code so you can detect any bug at the first place, the first time you run the code. And there may be many others. So let's start with the functions, variable names, and temporary variables. As I just said, functions need to be short. Most functions should be less than 40 lines. And this is by Google, not by me. Long functions are hard to read, understand, and maintain. Shorter functions force you to name parts of the code by creating helper functions and move parts of code into it and organize and structure your code so that you don't have redundant code that you don't need. And if you have duplicated code, you can also move them into helper functions and call them. And why do we want that? Because functions will overgrow over time. Each time when you want to modify the function, you may just say, I just need to add 2 more lines. And your function will grow and grow and grow. So what we want you to do is to refactor and extract new helper functions as you see your function is getting large. For variables, first, naming. We want variable names to describe their content and purpose, so we don't need to go to its declaration and read through the comments. And temporaries and scope. Best practice is to minimize the number of variables in scope so that we don't need to remember many variables that we don't need. So, which is why we should be using temporary variables. But don't overuse them. Only add those that will help with readability and add information. And we'll go through some examples next. Here are just the naming conventions that we want. First, the variable names need to be descriptive, and there are 2 choices for you to make. One is to use underscores to separate words, and one is to use camel case. But do not mix them. If you mix them, it's bad practice. And constants, also either make them start with a K or all capitals. We usually make them all capitals, but it's up to you, but do not mix these 2. Type and class names, all the types, classes, structs should start with capital letters, where your variables should always start with lowercase. And let's look at this chunk of code. From what I just said, any thoughts on this? Find 3-segment length. Any thoughts? And we have chocolate bars. Yeah, there's no vertical spacing. And let's add in the white spaces, vertical spacing. And next, consider the variables. So there are many function scope variables defined at the beginning of the function, and those are available throughout the scope of this function. And they're only used in certain if-else and not by others. And this can be potential initialization bugs because when you are using it, sometimes you will forget whether you have initialized it or not. And they are only used in some if-else branches. It's not required in other branches. So we want to declare variables at smallest scope possible, where they can be initialized when you declare them. So now I moved them into the if-else statements. Anything else? Let's consider the variable names. Are there any problems with the variable names? So we want them to be descriptive, right? Any thoughts that you want to share? Yes, and that's the next point. Yes, int1, int2, lat long, lat1 are not necessary declarations of variables. And before that, the variable names are not descriptive because first, you're assigning info.from, info.to into int1 and int2. And that means you are losing the information about from and to. And as you just said, there are redundant temporary variables. So, and what we want is to use descriptive variable names and avoid temporaries which are unnecessary and do not improve clarity of the code. So now we rename the ID to be streetseg ID, info to be seg info, info of street segments. Then we remove the temporary variable and put them into the functions and rename the lat longs to from and to. And we can further eliminate the variable length by just returning from the function. And we can even remove the temporary variables lat longs from and to by putting them into a function. So we are left with a single function call. But the last change may be unnecessary because this will add on difficulty in reading the code. So sometimes it is better to leave the temporary variables in, like this case, because it will allow you to better see your steps in the debugger, because you're separating them into different lines, and it improves readability, because now you're calling two functions within a function. So from what we had before, we shortened the function into this, where we have vertical spacing, we have descriptive variable names, and we have less lines. And these two temporary variables are just there to help understanding of the code. Okay. Yeah, let's continue. Comments. So what are the types of comments that we will need you to write, and which ones are more or less important? So if you look at the files that we gave you, in the .h files, in the header files, at the beginning, we have a large chunk of comments describing in detail what is in this file and how you should use them. At the beginning of the functions, we have small chunks of comments, usually in a few lines, describing what this function does and how you should use it. At the beginning of struct or class declarations, we also have a large chunk of function describing what this is and how you use it. At each beginning of each code block, we also have one line of comment, usually one line, sometimes two lines, describing what this code block does. Which of these are the most important comments to have? So when you're understanding a code, which is hundreds of lines, thousands of lines, the first thing you'll look at is at the high level comments, which is the documentation of the code. And when we're writing code, we want the documentations to be in the comments, not in a separate file. Because if we have it in a separate document, and when someone makes modifications to the code, that someone may forget to update that separate document. So we want documentations in the code, and when everyone modifies the code, they will modify the comment. The most important comments will give the big picture of the code, and it describes the why of the code, not how, because the code themselves will describe how. It will describe the overall structure and design choices. For example, when I'm doing my research and I got the project from someone before me and they graduated. And when I want to modify something in the code, I need to first consider why they choose to put it here, because I don't think that's the most efficient way. Then I'll need to go ask the previous author about why they need to put it there. But if they commented with why, then I don't need to bother them after they graduate, right? And where should we comment? As we just saw at the top of files, we need to have a large chunk of comment describing the big picture. At the beginning of class and data structure definitions, we need the comments to understand the data, and understanding the data can help us understand the entire program. Declaration of functions, how to call them, what it does. And at the beginning of chunks of tricky code to understand. But we need to try to rewrite them for clarity first. And then if we cannot clarify them more, put in the comment at the beginning and describing what it does and why we choose to use this type of format. Do not leave commented out code in your project. If you need to get the read record of something afterwards, Git has all your code history, so you don't need to comment out code to keep the record. And do not translate clear code to English. So we don't want you to over comment by translating some code that's really clear to English. And these 4 points are sorted with most important to least important. When the TAs are marking you, they will mostly check for the first 3. And the last one, if the TA is not careful enough, they might not notice it. But if you have really tricky code that you cannot clarify more, put in comments for both for you and your teammates and for the TA. Okay. Next, avoid duplicate code. Because it can likely be extracted into its own helper function, and it was likely copy-pasted from someone else. And if the copy-paste source has some bugs, you're copying bugs into your own code. And if the source, the program who wrote the source fixed that bug at the source, and you forget to copy that fix into your own code, that's also a common source of bugs. And let's consider this code. So we have a for loop, and within the for loop, it has 2 chunks of code that are almost identical. The only changes are from to to and from to. This is an example of duplicate code that we want to avoid, because these 2 chunks can be extracted into a function. If we put them into a function called insert unique, that does what those 2 chunks do, and you are pushing you're passing into it the different street segments from, street segments to, and street segment ID into them. Any comments on this code then? Let's look at this code. And let's focus on the comments. Are there any problem in the comments? Any thoughts on the comments? These two lines. These two lines. Any thoughts on these two lines of comments? Last call. Okay, so these two lines of comments are duplicated. They're saying the same thing and they're long. So let's just shorten it and use only one. And then in the next two lines, it is pretty clear that it's using one from and one to. So we are left with this function. And a higher level comment that describes the two lines. Next, I will be showing a demo. I need to open up my VNC. Okay. Let's go to the IDE demo. So for this demo, I will show you first in VS Code and then in NetBeans. Is this clear enough, or do you need a larger font? Okay, let's look at this code first. So in the code, we have the load map. We have the find street segments of intersection that we wrote before. And everything else is empty. And this means that if we go back to the terminal and if we run EC297 exercise 1, and we run the functional test for intersection, we will get one passing test if that is, I didn't make. If we run this test, we will have one passing test. And the other two failed because they are empty. So, which means that this code works. Let's just look at its style. Any thoughts on the style? It's mostly in load map, right? We don't have comments. And so in this demo, I will show you how your IDE can help you do most of the things. So we don't have any vertical spacing. And the indents are wrong here. So in this for loop, we wanted to indent and we want the brackets to align. Let's see how VS Code can help you with that. Let's highlight this code and right click, and we do format selection. And VS Code will auto indent for you. Let's revert this and let's look at the variable names. The variable names are clearly too short, right? So we want to rename them. Rename num to num enter. And VS Code is actually clever enough to only name those that you want to rename. And this X is too short. Let's right click and go rename symbol. Or you can do F2. X to be the num segment at intersection. And after a few seconds of loading, your VS Code will rename that for you. Let's also rename the I. Rename symbol to intersection. I'm just showing you the options that VS Code offers, and it may take a longer time than expected, but it will do its thing very cleverly. Still loading, still loading. Yeah, it's slow, but it will eventually do it. Let me rename the J. Yeah, we'll just let it run. So those are just a few options you have from VS Code. It might be slow, but it works. And there's another very useful thing from VS Code, which is when you have your cursor on some word, you can use Control D to select the whole word. So pay attention, I just use Control D. I have the cursor on some word and I use Control D to select it. Or we can use the J. And then after Control D, I use Control Shift L to select all of the J's in this code block. And I can just rename it like this. I set. And if I use I again, Control D, Control Shift L will select all of the I's, and I can rename it like this, enter. So that was Control D and then Control Shift L. And let's format this selection. And it's loading again. Okay, yeah. Save this and close it. Okay, so now I'll show you the NetBeans option. Let's go into the same file. And for NetBeans, you also have the rename option. So when you right click and refactor and rename, and rename this to non-intersection, it will really quickly do it. And if we use this, right click, refactor, rename, it will also really quickly do it. And when we want to rename the I, enter. Refactor, name, J. Actually, this is Isaac. This is num, that intersection. And I. And let's verify all of the things that we wanted to do. So it also does the job. And for NetBeans, just be careful because when I tried last time, it didn't work. So when you do the rename, you'll need to double check. Just do a quick, really quick double check. And for the format, let's try it. And NetBeans also does the job. It auto indents and it puts all of the brackets to be aligned. And then here's the thing that NetBeans has, but VS Code doesn't. This chunk of code, we want to make them into a function. Let's go refactor. And move. No, not move. Refactor and introduce function. And for this function, we want to call it load intersections street segments, because we want to load this. And refactor. And we didn't need those two parameters, so we can delete them. So NetBeans will then just move the chunk of code into a function, and it will get the function there. Those two parameters just appeared because I didn't change, I used the default. Let's do it again. Refactor, introduce function. And this time the parameters didn't appear. Introduce function, load intersection street segments. And we don't have the return type, we don't have any parameters. Let's refactor. And this is what you'll get. So NetBeans will put them into a different function. And this is actually a feature that NetBeans does, but VS Code, we weren't able to make it work. Technically, it should have this feature, but we cannot get it to work. If you're an expert at VS Code, maybe you can try it. And yeah, and for the renaming feature, yesterday I got some problem with that, but if you instead try to format before doing the rename, NetBeans will work. And yeah, that is what I want to show you for IDE. Let's keep this and exit. And let's just do a final make and run to make sure that this didn't alter the function in any ways. So we are still passing that run function. Okay. Let's have a 10-minute break and let's get back at 11:10. That's 8 minutes, 8-minute break. And the next part is on a really important thing. Use named constants, not magic numbers. Do not use magic numbers. I will see magic numbers every year. Let's look at this code. Any thoughts? From what I just showed you. From what I just showed you, we're looking for magic numbers. And we have many magic numbers here. Yeah, if we look at one of them, like this function, it will return -1 if we see any minus number, return 0 if we see any 0. And if we can get through the for loop, it will return 1. So this function is correct. It's just there are many magic numbers in there. So it's a coding style issue. Yeah. The first magic number is the 20. Because 20 in here, it represents the size of the array. But if we need to change the array size, we will need to change all of the 20s in the code. And we are also returning magic numbers -1, 0, and 1. We must read the code carefully to see what each means. So this is what we recommend you to do. We have 3 ways of defining constants. We can either use a constant variable like this. So constant variables are computed at runtime. All of the constants, we are using all uppercase letters. It can be a constant variable or a preprocessor constant using define. So if you use define, this constant will appear at compile time. I'll resume recording. We're just losing a few seconds of recording. Okay, let's move on to the second demo. So in this demo, let's just look at the check numbers.cpp. So this is the same function that we just saw. It checks for whether it has 0 or it has negative, or are they all positive. And from this array, we have one negative value, which means that it should be returning has neg. Okay. Everyone can understand this code and what we are expecting it to do. Let's go to the makefile and disable the warning. Disable the compile warnings here. So what I just did is I just disabled all of the compile warnings. So the compiler will only give me compile errors, not warnings. And let's do make, and let's run the program. Remember, we want to see a -1. But for some reason, this program gave me 1. Can anyone tell why? So we have the weights, and it starts with a -1, which means that we should be entering this for loop and returning has_next, which is -1. But why are we getting a 1? Can anyone tell from the code? Let's go to the make file again. Because there are no compile errors, let's enable the compile warnings. So -wall will enable all of the compile warnings. And let's do make clean and make. There is one warning here. So just parentheses around assignment use as choose value. But in this case, we are comparing, we are not assigning, which means that here we are missing an equal sign. And this, without a warning, is really hard to find. And let's make again and run. We will get -1. Okay, so that is an example of an important warning that we want. So even though most of the compile warnings may be not important and we can ignore them, but there may be some of these compile warnings that are actually important and can actually find bugs for us. Let's get back to the slides. And that is why we're asking for no warnings in your code. Because warnings will flag potentially problematic code like what we just saw, even though most of them are not important and they will not affect anything in your code. But if you leave some warnings in, it is hard to see those that are actually important. So just fix right away when you see a warning. And stay at 0 warnings. And this is also a field that will be marked by your TA. And when you're doing the compile command line, which -wall, g++-wall is the flag to tell the compiler to generate all of the warnings. And in the make files that we gave you, we turned on all of the warnings. So you don't need to do anything to the make file, but please fix all the warnings in your code. Any questions till now? We also ask you to group related data into classes. This is less important in the marking perspective. But if you can group all of your global variables, different vectors into classes or structs, we recommend using classes. This can be a source of defensive coding. And in this case, if you group all of the data related to segment into a class, then you can just declare one global vector instead of the 4 vectors. So this is less name pollution because you're only defining one global vector, and all of these names are local. Instead of these 4 global names. Yeah. So a class is a type. And this vector is a global variable. And they are like these two are storing the same things. Like it's using the same storage, but this is a single vector and you can access the 4 fields within the single vector. Yeah. And the last part of this tutorial is defensive coding. We want to let your code find bugs for you. This is also a technique to eliminate bugs at the first place. And defensive coding is using assertion in your milestone. So if you have this function, and this function is passing an intersection index. The first thing is to include assert.h from the C library, and you want to make sure that first, your intersection ID is valid. Second, the load street segments, the intersection street segments is loaded before calling this function. So what we want to do is add in one line, assert. First intersection ID needs to be greater than or equal to 0 and less than the number of street segments, or the number of intersections, less than the number of intersections. And if we just put, instead of number of intersections, we put the intersection street segments dot type. We also check for intersection street segment, whether it's loaded or not. If it's not loaded, then the size will be 0. And this assertion will fail. And if one of them are not satisfied, the output will say assertion failed, and it will tell you which assertion it is. And when assertion failed, the program will exit. And this is checked at runtime, and it gives useful error messages. So it tells you where it's going wrong. But this might affect your speed by a little bit. So if you are just lacking the last bit of speed to pass the performance test, you can just, before include assert.h, define mdebug. And this will disable all of the assertions in your code. This is just for passing the performance test. So when you submit, you can leave in this define mdebug flag in. But when you're running your own program, we still want you to do the assertions in your code. And another defensive coding is to set all of the pointers that you just deleted to null. This is to prevent you from using it again. If you do not set it to null, you may get some garbage value. And your program will likely crash at some point, or it won't crash, but your values will be wrong and weird. But if you set them to null, the point you use it the next time, your program will exit and crash. Will set fault immediately if you set it to null. So if you delete something and you don't want to set it to null, just make sure that this will not be reused again. And advanced technique is to add in self-checking code, and this is not required for this course. Self-checking code will just self-check your code while the code is executing, like writing in test or writing in validation functions. And this is not required for this course, but it could be a useful thing. And this is just an example of garbage values being propagated. Yeah, and that leads to our last demo. Let's get back to the previous demo again and open it. So we have this file and we want to add in that assertion. Include assert.h. And at the beginning of this function, we add in the assert. Intersection ID greater than or equal to 0. And intersection ID less than intersection 3 segments dot size. We want to assert this. Let's make and let's run the EC297 exercise 1. So we just verified that adding the assertion will still pass the test. And let's change the run tester to debug tester. Remember, running debug tester will, in your folder, test folder, you will see the actual test file. The first thing is to delete the other two that we are not looking at, the other two tests. Delete the other two tests and let's verify that this will work first. So we're setting the configuration to unit test release. Unit test release. The build target to build release test lib street map. And launch target to build release test list lib street map. Let's do it. It's building. and run it. One test passed. And now let's go into the test and just do a random one and change the intersection ID to -1. So here I'm changing the test. I'm changing the test case to -1, which should fail the assertion. And let's build and run again. Here, you will see the assertion failed. And it will tell you at source m1.cpp line 61, it failed the assertion. And let's go to m1.cpp line 61. This is the line of where we define the assertion. Okay. And then let's just show that the flag works. We define the n-debug flag here. And let's compile and run again. We see that the assertion is gone. And we're failing this test because I modified the tester -1. So define n-debug flag will disable all of the assertions in your code. And this needs to be defined before the include assert.h. Okay. And let's revert back the test case and it will pass. Okay. And that's it for the assert demo. So just as a summary, code will be read more than written by you, by others, so make it readable. Code will be modified many times, so keep your code short and avoid repeated code. Put any repeated code in comment and put any repeated code in functions and put any long chunks of code in helper functions. Keep the tests with the code. So assertions can be the simplest test to write with your code. And they will be run each time you run the program. So you can do it often and it won't take that much time. Keep the documentation in the code by using comments. If your TA has difficulty reading your code, that means deduction of mark. So do code reviews with each other and discuss. Make sure that throughout your group, you are using the same naming convention. Do not mix them. And learn what is readable. Try reading others' code, see if others' code are readable, and let others read your code and see if your code is readable. And only commit the changes that are reviewed and you have, and others are approved and you have validated that they are correct. So do not commit buggy code. And your milestone, project management, and code style rubric is posted on Quarkus that you can see. And that is the rubric that TAs will be basing on when they're marking you. And here are the additional resources. And that's it for today's tutorial. Any questions? If there are no questions, I'll see you next week. And if there are questions, you can come up and ask me.